tu nampak sana. Macam mana itu? Jadi kecil. Boleh. Kena pakai wire juga. Boleh. Tak ada connection langsung. Ganas tu. Sikit. Okay, now should be okay. Right? Itu yang nak present. Besar tak sana? Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, I hope everyone's able to hear what I'm saying. Okay, thank you. This one. Okay, so last time we have talked about apa nama? A classification model, where we start on the K nearest neighbors model. So now we want to look at we have 1, 2, 3 more models that we will be able to show these classification models. Okay, so the models that we want to look at today is this classification and regression trees models. Okay, we are going to go quick on this, and then we look at another one is on the probability models, and the last one is on the logic models. Okay, and then later on Wednesday and maybe most probably Monday next week pun cuti juga. So and then Wednesday next week we'll look at how to implement these three models using our software. Okay, so last time what we have done is we have looked at the K nearest neighbors model. So what we look at is in order for us to determine whether what we want to predict is in group A, group B, or group C. Okay, by looking at whether by looking at the neighbors of that observations. Okay, so if let's say that observations have a lot of neighbors that is in group A, that is going to be in group A. If that observation has a lot of neighbors in group B, that is going to be in group B. Okay? And similarly, if that observation has a lot of neighbors in group C, then that observation is going to be in group C. So we did not go through the the detail on how the computers come up with the code. Okay, because it's going to be very messy lah. But the idea that is the ideas when we look at the k nearest neighbors model. So what the computer is going to do is the computer is going to scan all the neighbors of the observations. Okay, so you have that observation, and then the computer is going to scan. Okay, how many? Okay, what are the characteristics of its neighbor? Okay, so if the observation's neighbor is color green, so then a lot of its neighbors are green, then the observation is going to be considered as green. Okay, you are talking about gender, if the neighbors of the observation are male, then it's going to become male. So that's the basic idea of the k nearest neighbors model. Okay, so what's differentiate this model with all the other time series model that we have looked at is that the models that what we are predicting is we are predicting a categorical variables. Okay, so it's not in terms of numerical numbers or continuous numbers anymore, but you are talking about a categorical variable. So something like male, female, or talking about color, blue, green, white, yellow. Okay, so that's the idea when we use this categorical classifications models. Okay, so we have looked at that k nearest neighbors. So another ways on how we can model this data is to use this classification and regression trees models. Okay, it was developed sometime in the early 80s. So it means that this model are still something that is recent. And if you are looking from an econometrics perspective. Okay, but if you look at from the computer science perspective, it's already something that is old. Okay, so the, uh, so there are a lot of different classification and regression trees models. So the classic is this CART model, CRT models. Okay, and then you have other models. Basically, are using similar concept. So the concept that we are looking at is just this CART model, classification and regression trees models. Okay, so let's me goes to this one. So just to show how advanced is the thing that we are talking about. So I'm using this slide. I'm going to be using a few slides from the Masters of Science in Computer Science. Okay, from this university. Okay, looking at the decision trees models. Okay, so now we are really looking at big data analysis. Previously, what we have looked at is combinations of time series analysis and big data. Okay, but here is this really machine learning analysis where the machine are the one that's going to be the one that's help us to decide what is going to be the predictions. Okay, so what is a classification models? Okay, so we have different type of classification models. So usually for a classification models, you are going to have a data sets that look like this. Okay, so this is unlike our time series models where if we look at when we look at our data set are just discrete variables, are numbers. Okay, so now we can have a qualitative data, but in the end, what's going to happen is we are going to transform these qualitative data into quantitative data. Okay, so let's say we look at the first column obviously are numbers. Okay, the second columns are, I think this is employment or employability. So we have state government. Okay, this guy is working with. You have someone working with a state government, someone who is self-employed, someone working with a private in a private sector. Okay, so those variables can be coded as 0, 1, 2, 3, 4. Okay, so private is different values, state government different values, and employed different values that can be done automatically by the computers. So you have the education level: bachelor's, high school graduate, 11th grade, and 9th grade, masters, and all those things. Uh, the one, two, three, the fourth column is number of years, educations, marital status, job, relationship, relations, husband, not in a not in a something. Okay, and then race, okay, gender, hours of work. Most probably this is hours per work, hours of work per week, countries, and whether the person is whether poor person is or rich person. So most probably what happened over here is we have the data for income, and then they classify as poor as a certain range, and rich as a certain range. Okay, so you have these 16 attribute, or you have these 16 variables. Okay, so classification, so is a major data mining operation. So basically, what we are trying to predict is we are going to predict one attribute or one variables, one categorical for one qualitative qualitative variables. Okay, using the values that we get from other variables or from other attributes. Okay, so down there you have a definition, a categorical attribute, and an attribute which takes two or more discrete values, also known as symbolic attribute. So this is the word used by computer science. Okay, so because computer science involve a lot of data, okay, because they are the one that control the database of different companies, the database of different organization. So uh, they need to know how to arrange, how to organize the data. Okay, and later on how to present the data. Okay, and so they are using this term, categorical attribute and real attribute. We also have in econometrics, you have the qualitative data, so you have quantitative data. So categorical attributes is your qualitative data, and your real attributes is the quantitative data. Okay, but in the end, when you want to analyze, usually what's going to happen is you are going to change from a qualitative attribute to a certain numbers. Okay. 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 So this is what we have in the data set that I've shown you before. Age, education, numbers, race, hours, work, employment, marital, gender, countries, wealth, and all those things. Okay. Okay. So what can you do with the data set? So usually the first thing that you want to do with the data sets, you want to describe the data sets. Okay, so the easiest way to describe the data sets is you can just look at that there's different histograms that you have over there. Okay, so first one, you have that data. They differentiate by male and female, how many male and how many female. Okay, they differentiate by gender. Okay, they can differentiate by marital status. Okay, sometimes the histogram is also called a contingency tables. Okay, so different discipline going to have different names. Okay, if you study sociology, okay, uh, they are going to be using different terms. If you are studying engineering, sometimes they use different terms. Okay, so this is a two-dimension contingency table. Okay, where we break up the the poor person and rich person by age group. So if you look here, age group tens. Okay, so this is people who are between 0 to 10 years old. 2,507 are poor. Okay, and 3% are rich. So most probably their parents are very very rich. Okay, and they are given certain income. Okay, you have a lot. You have a lot of this. Okay, born. These are the people who are born rich. So similarly, in the 20s, 743 that are rich. Okay, so this is one way to describe the data that you have using two-dimension contingency table. So you differentiate the poor and rich by age group given the data that you have. Okay, so these tables provide more information to the data. Okay, so you still have a histogram. Okay, so now you have a histogram, but now you are given here uh, because the number three is small, very very small relative to 2,507. So you not be able to see the color red. Okay, so the blue and red are basically percentage of people who are rich and poor in that different age group. Okay, so if you turn around the histogram, okay, you turn around the histogram and you really look at the histogram and you can put a percentage. Okay, then your table, even though it's still a two-dimension table, the table have more information. Okay, telling you uh, the number of people, okay, who are poor and rich. So here, okay, you can put it into percentage. So in each group tens, almost 100% of people are poor. Okay, and then you have the different age group. Okay, so you can see okay, how you can put more information to this different table, to these different charts that you have. Okay, in fact, if you go through all the government report, okay, you go through government report, you will be able to see all these different chart. Okay, so that's why I say presentation is one of the things that is very very important. Okay, for you to for when you want people to understand what you are trying to show. Okay, so if you just if you're when you draw a graph, you usually if you put these numbers, it become very very messy, right? Okay, so that's why you want to have something that is clean. Okay, you just show this thing, okay, and put a small percentage over here that it is able uh, to explain a lot about the data that you have. Okay, so this is another way to present the data that you have. Okay, so previously you have about 16, 17 variables. So this show marital status. Okay, and what type of jobs these people are having. Okay, so yes, someone who is divorced. Okay, how many people are administrative clerical work, who are in craft, who are in farming, who are in machine operations, uh, private housing service, I don't know what's that, protective service, technical support, and then yeah, missing values. Most of the time, missing values, you don't put missing values lah in the data. So now your data become much now more beautiful. Okay, you become much more your data become much more colorful. Okay, so this is just in term of presentations. Okay, to give you some ideas. Because later on you also have to come up with a report, right, for your papers. Okay, so you can have a 3D contingency table where you can have three different variables, age, whether rich or poor, male or female. Okay. Uh, so you can also use this online analytical processing software. Okay, for you to present your data. Uh, okay, so if you have not heard of Microsoft BI, anyone have heard of Microsoft BI, Business Intelligence? Okay, so that is one of the software that are used by many companies. Okay, so maybe you want to try to learn how to use Microsoft Business Intelligence. Okay, let me show. What, okay, so let's look at this one. Slow pula dah. Okay, Microsoft Power BI. Okay, the Power BI will be able to help you to come up with. Oops. See, it's free. Okay, Microsoft BI will help you to come up with this type of table. Okay, so even if you don't know how to draw this nice thing, okay, this software will be able to help you to chart all this table. Okay, you can just give you can provide the data, and the software will be able to help you to tell you which data are best suited to explain which type of graph is best suited to explain the data that you have. Okay, so uh, and this software is used by a lot of different companies. Okay, it's like here. Uh, tak keluar lagi. Oh, ni ber juga. Ada gambar tadi. Okay, so anyway, so what this software will be able to do is it can get data from your Excel. It can get data if you have data from Microsoft Word and everything. It will be able to help you come up with all these nice graph. Okay, so they can even come up with this ni. Mana tadi peta tadi? Yeah, so all this map. So if let's say you have a data, okay, let's say you have a data where you have sales from different companies. Okay, you have sales from different companies or in different countries. Okay, so you have data still in Kuala Lumpur, data of sale in London, you have data of sale in Los Angeles. Okay, then you have the data. Then this Power BI will be able to help you come up with this graph here, okay, where you have the map of the world and you have all this data and data for sale in these different okay, in these different cities that you have the data for. They will be able to help you to come up with a dashboard of all the informations that you have. Okay. Anyway, let's come back to thing. Okay, so why is it that we want to look at this contingency table? Because this contingency table, okay, and if you are able to come up with a dashboard, okay, whether a dashboard on Excel or dashboard on Power BI, it will help people to understand the data that you have. Okay, but sometimes too much data is not good. Okay, so previously the data that we have 16 attributes. So if we have the one dimension contingency table, we can have 16 table. Okay, if we are coming up with a two dimension contingency table, we can have 120 type of tables. Okay, you're talking about three dimension 560 three dimension table. Anyway, so the idea now is sometime when you come up with the table, you don't want to have too much table lah. Okay, so what you are trying to do, you're going to try to extract as much as possible and as simple as possible to present all the data that you have. Okay, so what we are doing now, in a way, we are doing simple data mining. Okay, we are going to automate a process of searching for patterns in the data that we have. Okay, so in fact, when you do that k nearest neighbors, okay, we are doing data mining. We are searching for pattern based on based on the data that we have. Okay, asking computers to search for the pattern. Okay, automatically search for the pattern. So different from when we do our ARIMA model, or we do our ER model, and we do our MA model, where most of the work are still manual, where we are the one searching for the pattern and decide, okay, which is the model is the best model. Okay, when we do our exponential smoothing, okay, so basically what we tell the computer to do, we tell the computer to do this exponential smoothing. Okay, but we do not but we do not automate the process. Right? Can the process be automated or not? Yes, the process can be automated. Uh, what we can do, we have the data. We can write a simple code saying that you ask the computer, hey, you do exponential smoothing, you do the three exponential smoothing, you do ARIMA, you do all this thing, and then come up with the results. Okay, and show which of the model is the best. Okay, then the question is, the computer is going to ask you, how should I choose? Okay, so one of the way for you to say which model is the best is to look at the model that have the lowest root mean square error. So you tell the computer which model have the lowest root mean square error. So if that is the decision, and that is the way how the computer decide, then the computer is going to choose the model that have the lowest root mean square error, and that's going to be the best model. Okay. So, so even though previously what we have done is something that is manual, we are the one that choose which model is the best. But we can still okay, we can also automate we can also automate the process. Okay, so what we have to do is we have to tell the computers how to decide. Okay, but the same thing what we are doing over here in this data mining, we are telling the computer what to do, and how to decide. Okay, it's similar to when we talk about machine learning and all those things that you have currently are very, 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 very popular. Okay, similarly, if you are talking about Tesla, everyone know about Tesla, right? Okay, so Tesla can drive itself. So how does Tesla drive itself? So basically, all the engineers and all the data scientists teach the car how to drive. Okay, they are going to drive the car. Okay, and all the data is going to be saved on their storage on the computers. Okay, and from there they come up with a pattern. When you drive, what are the things that the car is going to will see. Okay, when you drive, okay, when they teach the car how to drive, there is a manual driver. Okay, the manual drivers, in a way, putting all the information into the car. Okay, similar to what we are doing over here. Okay, so the thing now is, why is it that we can have a self-driving car? Because the power of the computers become very, very cheap. The computer can save a lot more data. Okay, so when the car move, okay, you have the apa nama ni, dia punya satellite, kind like a sonar or the benda ni. Okay, see, okay, what are the things that in front of the car, beside the car, behind the car, right? Okay, so from there all the information are stored. Okay, and when they move, they're going to try to extract all the informations that they have in deciding whether to stop or not to stop. Okay, similar to the process, the process that we have when we walk. Okay, so what happened to the car? Okay, so when the engineer teach the car how to drive, is similar to when we were very very young. Okay, 1 years old, 2 years old, 3 years old. Okay, we have other people teach us how to what we need to do. Okay, it's just that now, previously, 10, 20 years ago, we do not have that computer that will be able to process all the information very very fast. Now we have computers that they are able to process the informations. Okay, in fact, now the way the computers process information is maybe much faster than in certain cases much faster than our brain. Okay, but in the end the process are the same. Okay, you have someone teach the computer what to do. Okay, writing all the code are teaching the computer what to do. Okay, we are the one teaching the car how to drive. Okay, so so the teachers is very very important. So the teachers are the one that's going to put values to the car. Okay, whether the car have values or not. Okay, so because sometimes the car, if let's say you have a car, okay, and then the car is going to crash. Okay, and in front of the car you have a small kid and you have a young adult. Okay, the cars is not able to for the car is not able to go to the right or to go to the left. Okay, in order to move away from the kid, or the adults. The cars have to decide whether to hit the adult or whether to hit the kid. Okay, so that's where the values come in. Okay, so when we were young, we were taught all these values. Okay, but similarly for the cars have to decide, uh, have to be given values. Okay, what the cars need to what the cars need to do. Okay, so that's why even though we have all these computers, humans are still very very important, because humans are the one that's going to give values to the cars, that's going to teach values to the cars. And the same thing when we have all these data. Okay, how do we interpret the data? How do we interpret the data depend on the values that's given to us, right? Okay, what we should do, what we should not do. When we have all the data, we can do a lot of different things. Okay, something is good, something are bad. Okay, so when you have data for all the consumers, okay, if let's say you are responsible for data for Giants. Okay, uh, okay, so now you want to decide. Okay, uh, uh, you need to decide uh, a marketing campaign. Okay, so in deciding a marketing campaign, okay, so there are certain marketing things that are Islamically right. There are certain marketing things that are Islamically not right. Okay, so that's where the value come in. Okay, and so you have to decide. Okay, if uh, which one is right. Okay, it may be the case where something that is Islamically right is going to give a lower profit compared to something that is Islamically wrong. Okay, so those who have values will go for the profit. Okay, those have the Islamic values, then will go for the Islamic values, even though the profit is going to be lower. Okay, so uh, that's where values are going to be very very important. Even though we are just talking, people say that, right? how can we make all this data Islamic? Okay, how can we make this data? People usually going to say that data are value free. Okay, but data are not value free. Okay, so how we interpret the data, okay, going to depend on our values. Okay, and we want to interpret the data to be as Islamically as possible. Okay, so when we doing this data mining, okay, we want to see which pattern are interesting, okay, which pattern are just illusion. Okay, so similar to when we talk about when we are doing our ARIMA models. Okay, we want to we want to really see a real pattern. Okay, not just an illusions. Okay, something that we don't talk about in the class when we talk about time series previously is co-integration. Okay, so co-integration is talking about relationship in the long run. So when you have a relationship, the relationship can be a relationship in the short run and a relationship in the long run. Sekejap. Ada orang nak masuk, tak boleh masuk ke? Sorry, mana nak pergi dia? Okay dah. Hopefully okay. Okay, so anyway, when we talk about relationship, if we are talking about time series data, something that we did not talk about last time. Okay, a relationship in the data that we have can be relationship in the short run and a relationship in the long run. Okay, so let's say you have a data here, whatever is the data, y, x data, and this is time. Okay, so let's say this is variable y and this is variable x. Okay, so this is time variables and this is the values. So you have the data that's moved like this. Okay. So it is moving together both in the long run and both in the short run. And you have a data that is co-integrated. Okay, so that's where which pattern is interesting are very important, which might just be a mere illusions. Okay, so these two variables y and x are co-integrated. They have a relationship both in the short run and the long run. Okay. But now let's say you have another data that look like this. Or this is z. So if let's say you run a regression between variable y and variable z over here, or variable x and variable z here, your R square is going to be most probably 0.9. Okay, between y and z. Okay, so that's what you are going to get. The R square is going to be very, very high. And why? Because both are trending upward. Okay, so people may say that there is a relationship between y and z. Okay, but there are a lot of times there is no relationship between y and z. Okay, even though both are trending upward, because if you look at the short run, there is no relationship. Okay, so you have a relationship just because if you run a regression, you are going to get a R square that is very, very high. This R square is very, very high because just because of Z is turning into. Okay, so for Y and Z to be to have a relationship, okay, you need both to both to be moving, both to be moving together. Okay, and when they usually when they describe these co-integrations, it is between a person A and his dog. Okay, so a person is walking his dog. Okay, so what is going to happen when you are when the person walk his dog or walk his cat? Maybe I think we have got. I saw a lot of people walking his cat. Okay, Malay are walking his cat. Anyway, so when that person walk, okay, so the dog may move away from him a little bit, okay, but in the end, the dog will always follow that, will always follow the person. You will have a relationship that looks like this. Okay, so if you have a relationship that looks like this, then you have co-integration. Okay, so that is where if when we look at the data, okay, we want to look at patterns that are interesting, and we also want to differentiate. We want to see whether that patterns that we see is just a mere illusions. So the relationship between Y and Z are something that is just a something that is just a mere illusions. Okay. So that's what data mining is trying to do. If we want to have both relationship in the short run and relationship in the long run. Okay, so which pattern are interesting? Uh, okay, so to see which pattern are interesting, then we have to that's why we use all these different model to see which pattern are interesting. Okay, so let's go back to the slide. Okay, so now let's go back to this our original slide. Okay, so what we want to do is we want to use this classification three models. Okay, so what are the computational details that what's the computer is going to do? Okay, what the computer need to know. Okay, so first is the computer need to know what are the criteria for predictive accuracy. Okay, so what is the decisions? What is the decision criteria when the computer is going to say this model is good or this model is the model this model is not good. Okay, so previously I talked about the RMSE, root mean square error, the minimum root mean square error. Okay, so basically what the computer is going to do, the computer is going to compare different models. Okay, and what's the root mean square error? What the models that with the lowest root mean square error is going to be the best models. Okay, so we have to specify the criteria. Okay, so one of the criteria that we can use is the lowest misclassification rate. So what does this lowest misclassification rate mean? Okay, so what's going to happen is if we look at back to the earlier examples that we have. Okay, what we want to predict is we want to predict whether someone is rich or someone is poor. Okay, and to predict whether someone is rich or someone is poor, we have all this. We have the 15 other attributes that will be able to explain. Okay, so the computer is going to be using some of the attributes that we have and determine whether the person is rich or poor. Okay, sometime the computer is going to be making error or our model is going to be making error. Okay, so what we want is we want to have we are going to choose the models that going to have the lowest amount of error. Okay, and then we have to decide what do we mean by lowest amount of error, right? So let's say one is 100 error, and another one has 10 error. Okay, which one is low, 100 or 10? Okay, everyone is going to say 10, right? Okay, then it's going to depend what is our sample. Okay, if the samples that we have over here is only 500 observations, here the samples that we have is 1,000 observations, then this is bad lah. Okay, but here if let's say the samples that we have over here is 1, 2, 3, 50 million observation, then this is very very good, right? Okay, so it's not just the absolute numbers. Okay, sometimes it's the relative numbers for us to decide. Uh, Selecting split. Okay, later on we are going to talk about what does it mean by splits. Okay, when to determine when to stop splitting. So again, we are going to look at when are we going to stop splitting the data. Okay, and selecting the right size of tree. Okay, so basically in this classification models, we are going to have a tree. So we are going to have this tree. So how do we split so that it's going to become a tree? And when do we want to stop splitting the tree? Okay, so in our example, we have 16 attributes. Right. So what we want to decide is we want to know whether someone is poor or rich. Okay, so in the end, if let's say we start from a root over here, rich or poor, rich or poor, rich, poor, rich, poor. Okay, so we want to know at the end over here whether a person is rich or poor. Okay, so since we have 16 attributes, we can break up the tree into 15 levels. Okay, but usually we don't want to have something that is a tree that is too big. Okay, we want to have a tree that is much smaller. So that's what we mean by splitting the trees. Okay, or pruning the tree so that our trees become is not too big. Okay. Okay, so this is an example of a decision trees. Okay, so let's say we have the variable here, and what we want to decide is whether someone is going to cheat or not to cheat in a tax filing. Okay, so I think everyone, or if you still don't know, uh, when you work, if you reach a certain amount of income, you have to pay income tax. Okay, so in a lot of countries, the basically what's going to happen is you are going to declare your income. Okay, and after declaring your income, certain amount of tax then there will be certain amount of tax that you will have to pay. Okay. Okay, the thing is that there are a lot of people going to cheat the amount of income that they get, so that the amount of tax that they have to pay is going to be less. Okay, so what you have is you have a simple model over here that's going to decide whether someone is suspected to be cheating or not to be cheating. Okay, so if LHDN suspect that the person is cheating, then what the LHDN is going to do? The LHDN is going to go and audit the person. Okay, okay, so that's why everyone have to save 7 years of their income statement or receipts that they have, because LHDN have 7 years to audit a person, or sometimes not just a person, they also can audit companies. Okay, you have cases where LHDN officers uh, go and sit in front of the cash register, see how much income does a restaurant get in a day. Okay, so that they will be able to determine how much tax that the restaurant have to pay. Okay. Okay. So anyway, so this is an example of the decision tree. So you have one, two, three, four variables. The first variable is refund. So whether the person get a refund or not getting a refund. Okay, whether the person is a single, married, or divorced. Eh? How much is the taxable income, and whether the person cheat or not cheat. Okay, so they already have this data. Okay, and what they want to do is they want to predict whether someone is cheating or not cheating. Okay, so we can split the data into these three. Okay, so what you have is we start with a refund, yes or no. Okay, and if you look at the data that we have over here, yes, no cheating, yes, no cheating, yes, no cheating. Okay, so we have one, two, three, yes. See? So all three yes, all three person who get a refund did not cheat. Okay, so that's why it stopped over here. And the person with no refund, okay, okay, then we have with person with no refund, we have person with no refund, no cheating, no cheating. Okay, we also have person with no refund that is cheating. Okay, you also have person with no refund that is cheating. So number 8, number 10, and number 8, number 10, and number 5. Okay, no refund and cheating, right? Okay, so refund yes, and refund no. So refund yes. Okay, so tak nak tekan dah ni. Yes. Okay, so refund, no refund. Then we look at the marital status. So marital status, single or divorce. Okay, and then marital status, married. So no refund and married, no cheating, no refund and married, no cheating, no refund and married, no cheating. So that's why we end up over here. Okay, and then uh, eh, single and divorce, then we have to break it up into taxable income. Okay, whether taxable income is less than 80 or taxable income is bigger than 80. So if we look at here, the uh, if we look at if we look at this tree, so what's going to happen? The computer now the computer is able in a way to provide a probability, okay, whether the person is cheating or not. Okay, so just looking at this table, if a person get refund, okay, if a person get refund, the probability that the person is going to cheat is zero, right? Okay, so that's how that's how the computer is going to decide, okay, uh, uh, whether the person is going to whether someone is going to cheat in their tax refund or not cheating in their tax refund. Okay, so this is just one way to model the decision tree. So this is another way to model the decision tree. So instead of starting with the instead of starting with refund, we can also start with a marital status. Okay, so the computers will go through all these different possibility. Okay, so where to the possibility of where to start. Okay, and looking at all this possibility, then the computers will choose which of the model is the best models. Okay, so this is what's going to happen now. Okay, the computer is going to learn the models. Okay, in trying to see in trying to come up with a model uh, who's going to cheat or not. So usually what's going to happen, similar to what we have done with the K nearest neighbors model, uh, you are going to have a set of data. Okay, so let's say this is the set of the data that you have. Okay, you may have 100 observation, 1,000 observations. So what the computer is going to do, the computer is going to divide the data into two. Okay, one is the training set. Okay, and the other one is the test set. Okay, so if you still remember your the key nearest neighbors that we have done last time, what we did is we break up the data, 70% of the data in training set and 30% of the data in the test set. Okay, so this doesn't matter lah. So you can also have this to be 90%, this to be 10%. Okay, whatever is the breakup that you want. Okay, you have the training set and you have the test set. Okay, so the training set is going to decide the models. Okay, kind of deciding what is going to be what's going to be the beta and those things. Okay, and this test set, they are going to be using the result from this training set, okay, to test, okay, whether the model is to test which model is the best model, okay? which model is the good model. Okay, so from here they will be able to come out, okay, like, okay, to look at this predictive. Okay, this test set will help us to see what is the predictive accuracy. Okay, and this predictive accuracy is going to tell you which model is the best. Then you are going to be using the models that is given by this test set to predict. Okay, so this is the data that you have. You have the data. Okay, so for to predict, you don't have the data yet. Okay, you don't have the data. If you are talking about the cheating or not cheating, you do not have the data cheat or not cheat. You only have the attribute, the variables. Okay. Okay, so for you to predict, so what you want to predict this no or yes, right? Okay, so for you to predict this no or yes, okay, so initially you have all this data, the data of no or yes. Now you want to predict, you don't have the data of no or yes, but you have the data of refund, marital status, and taxable income. Okay, having this data, then you will be able to predict whether someone is cheating or not cheating using this decision tree, the decision tree model. Okay, so now let's say you have done this. Okay, you have done this. What you want to do is you want to predict. So basically, what's going to happen if let's say you use this model. Okay, you want to see whether someone have a refund or not. Okay, if someone do not have a refund, okay, then okay, if someone have a refund, then you know that he do not cheat. Okay. Now then, if let's say someone do not have a refund, then you will look at what is his marital status. If he is married, then the model is going to say that he do not cheat. Okay, if the person is single or divorced, then the model is going to see what is his taxable income. If his taxable income is lower than 80, then the model is going to say that he did not cheat. If the taxable income is bigger than 80, then the model say that he is cheating. Okay, so that's how the model that's how the computer is going to the algorithm that the computer is going to be using in order to decide whether someone is cheating or someone is cheating or not cheating. Okay, so it is possible that no refund, marital status is single, and taxable income is 80,000. Okay, but the person do not cheat. Okay, so that's why there is we have the possibility of error. Okay, so because this is just a model. Okay, so let's look at another example. So this is the example that we use in our K nearest neighbor model. So what we want to try to do is we want to try to decide whether the insect that you have over here is in the Catadid group or in the grasshoppers group, right? And what we do is we just want to use two variables in order for us to decide, okay, whether the insect is a grasshopper or the insect is a Catadid. So whether we just use antenna length and abdomen length. Okay, and last time we have already decided whether the insect is a grasshopper or Catadid. So which one is which? Okay, so if let's say we want to use these classification tree models, we can also use the classification tree models. So what we can do is we can start with an abdomen length. Okay, so abdomen length, and then we look at antenna length. So what you have over here, so you also have a decision tree. And we start with an abdomen length as the root. Okay, then we look at antenna length. Okay, and then we can decide. So what the computer is going to do is the computer is going to play around with these lines that you have over here. Okay, because what you have, the computer is deciding abdomen length, the grouping to be bigger than 7.1. Okay, and then you have antenna length, the grouping is bigger than 6. Okay, so for for you to be able to decide, okay, how to group this, then you need to do this trial and error process, right? Okay. So what they have done is they look at the data, they go down the data, okay. So what they see that they look at the abdomen length. Okay, anything that is bigger than 7.1 is going to be Catadid. So that's why the computer decide the break point is 7.1. So because anything that have abdomen length bigger than 7.1 is Catadid. So if abdomen length is 7.1, yes, then it's become Catadid. If abdomen length is less than 7.1, then the insect can either be Catadid or can be a grasshopper. So now, how to break up this antenna length. So then they find out that apa nama ni? Anything that have antenna length that is bigger than 6. Okay, if abdomen length is less than 7.1, is Catadid. Okay, so and if the antenna length is less than 6, then it is a grasshopper. So that's how that's what the computer is going to do. Okay, so in this case, there is no error, right? Okay, so in this case, there is no error. Okay, but you may have a point where, for whatever reason, you have a grasshopper over here. Okay, so you may have that. So in this case, when they give an example, that is nice, where you don't have an outlier. Okay, but there may be an outlier. So if there is an outlier, it's going to show that there is one point where the model is not able to explain. Okay, so in this case, the model is able to explain everything. Okay, but there is a possibility that the model are not able to explain everything. So that's why there will always be an error. And what we try to do is we are trying to reduce the error. So that's the question. How are we to split the attribute? Okay, and how are the split values chosen? So that's the question. So how do we answer the question? So that's where the algorithm of the computer is going to come in, and what the algorithm is going to try to do. The algorithm is going to try to minimize the error. Okay, but in trying to minimize the error, there are a few things uh, that the computer will have to try to some of the issues that the computers do not want to get into. Okay, one is the issue with overfitting. Okay, so the question was, when do we stop splitting? Okay, so if we have here, uh, okay, the example that we have is very, very nice. So that's why. Okay, so we just have thing like this, right? Okay, so let's just start with this one. This is antenna, and this is abdomen. Okay. So the graph that I'm drawing is totally different from the graph that you are seeing on the uh, on the on the screen. Okay, so if we have a classification that look like this, then then you can just decide to split over here, right? Okay, you can decide to split over here, whatever is the value of abdomen over here, or you can split over here, whatever is the antenna length. Okay, so what's going to happen? Your decision trees will only be one layer. Okay, you don't have to go to two layers. Okay, so you can either use antenna length as your model, or you can use abdomen length as your model. Okay, so this is this is what we mean by this overfitting. Okay, so if you can fit the models, okay, without the need to have another layer, okay, then you do not want to add another layer. So if you add another layers, then you are overfitting the data. So if you don't need to add another layer, then you do not want to add another layer. Okay, so the example that I'm showing over here is very, very simple. Okay, it is clear. It can be clearly seen. But what if okay, but what if we have Okay, but what if what you have is over here? Okay, try to make it more complicated. Okay, so if you have something like this, then for sure, then that's why you need to have another layer, right? Similar to what we have done before. So even in this case, this, so that's why we want to have this. Okay, and we break up over here. Okay, but what's going to happen is what we did is something like this. We are still not able to explain this. We are still not able to explain these two, right? Okay. So what's going to happen? So basically, what's going to happen? We are just going to say that we are not able to explain these two. We are just going to say these two just that may be an that's going to be an outlier. Say that's going to be an error. Okay, unless we can have a model that is able to split the data. Okay, so let's say if we can have the computer can come up with a data. So if we have very, very powerful computers, okay, the computer may be able to come up with this type of split. Okay, but to do this in a tree, it's almost impossible lah. Like where you are going to have more layers. Just try to explain that. Okay. So, but what if you have ada pula kat sini? Then it is almost impossible. Okay, because sometimes the pictures that you have in your screen is something that is simple, but when you are talking about the real world, it's going to become more complex. So when the worlds become more complex, there are times when you are not able to, your model will not be able to explain this, and you have to take it that your model you are not able to explain that. Okay, so that's why in this case there will be the R square. If you are talking about R square, the R square will not be 100. If you don't have this, basically the R square is 100. Okay, you are talking about R square. Okay, so one is when we are talking about overfitting. So when we are talking about overfitting, we do not want to put too much variables. We do not want to include too much variables. Okay, and then what we want to do now is we want our model to be as simple as possible. Okay, sometimes we want our model to be as simple as possible. So that's why the example that we have is just this straight line, okay, rather than this complex. Okay, we just have this model, something like this. Okay, rather something that is very, very complex. Okay, okay, let's stop over here, and then on Wednesday, then we can look at how to implement this classification tree and regression tree models. Okay, and then if let's say we are able to do that, we are able to complete that, then we'll look at a more complex model, this base formula and then the logic model. Okay, so let's stop over here. Assalamualaikum warahmatullahi wabarakatuh. Sejuk.
Thank you, sir.
Okay. Dah pergi semua dah. Kat sini. Okay, see you on Wednesday.